Hi guys, for today's lesson we're going to be dealing with continuity and piecewise functions. So first up, some words to remember. What do I mean by this idea of this word of continuous, which relates to continuity? So continuous is a word that describes a function that can be drawn without lifting your pen from your paper. So it's pretty much like the graph is pretty much like a continuous sort of line. Discontinuous is a function which has a gap in its domain, i.e. it is not continuous. You can't draw these sorts of ones because it has some sort of gap where you'd have to lift your pen, if that makes sense. So this sort of graph is an example of a discontinuous graph. You can see here, if I was going to draw it, I'd have to do this part of your graph, and then I'd have to lift my pen and do this part here. It's a discontinuous type of graph. Its discontinuity is at x equals 0. You'll notice here that there's no value here for x when x is a 0, because look at our equation. If our x is a 0, this function becomes undefined. You can't divide by 0. So therefore, it's discontinuous at x equals 0. The gap is along this y-axis, because this is where our x is equal to 0. So yeah, hopefully that makes sense. Okay, so piecewise functions. So functions which have different definitions for certain parts of the domain. So piecewise functions usually look something like this. We've got a y equals, which is pretty typical, or it could be f of x equals as well. And then you've got this kind of fancy bracket here, and it shows you two different functions inside the brackets. And pretty much this piecewise function is both of these functions at the same time, just for different values of your domain or your values of x. So when x is greater than or equal to 0, we can see here that for everything greater than or equal to 0, all our positive x values over here, we can see that our function is x squared. So that's why we see this parabola over here. When you get over into the negative values of x, when x is less than 0, we can see that our function is negative x. So we get a line which has a gradient of -1 and a y-intercept of 0. So we get this green line here. And we pretty much join up these two functions on the same graph. So this graph here is this piecewise function right here. This graph actually is continuous, and the reason is because I can draw these without lifting my pencil. So this is what we would consider this piecewise function to be a continuous graph. Okay, example 2. This is another example of a piecewise function. It has 3 parts to it, which is perfectly fine. And you'll notice that this is a discontinuous graph, and the reason is because I've graphed each of these functions at their right spots. So the graph of 5 is a horizontal line, which goes through the y-intercept of 5, but this is only for x being greater than or equal to 2. So that's only when our x is above this 2 here. So that's why we've got this line graph just for that section. Next up is 2x minus 3. That's just a linear line with a y-intercept of -3 and a gradient of 2. That's just between -2 and 2. So that's what you see down here. There's your graph there. And then lastly, for x is less than -2, so all this stuff down here, we've got a parabola. So you can see only a little part of your parabola. This part here is kind of shooting straight up. Now you'll notice these kind of circles that are not coloured in and coloured in. That suggests the values at these specific values. So for example, when x is equal to 2, we can see that y is equal to 5 because that's where the circle is coloured in. It's not equal to 1, which is down here. Down here you can see that when x is -2, the y value is down here at -7. It's not here because it's not circled in up there. And the way that we know this is based on whether x is equal to or less than, etc. So because the y is equal to 5 when x can be equal to 2, that means at 2 we have to make sure this is coloured in for this function here, for this function of y equals 5. And same down here, when x is equal to when x is equal to -2, it's equal to this green function. So that's why our coloured in circle, it's coloured in down here on this green function and not on the blue function, which was x squared, which is just less than -2. Okay, so let's do some example questions. So determine whether the following piecewise functions are continuous, i.e. you can join them, like you can draw them without lifting your pen. So here we've got our piecewise function. We can see that we've got two separate functions here, and they kind of cross, or they kind of change over at x equals 2. That's like your point when they swap from one function to the other. So the strategy is that you check that both functions are equal, i.e. have the same y value, at the changeover x value of +2 that we can see here. So all you need to do is substitute in 2 into both of the functions, and we can see that they both equal 7. That means that they will link up at that changeover point because they'll both have the same y value of 7, even though they'll look different. Therefore, because they link up, we can pretty much draw these without lifting our pen. Therefore, the function is continuous. We'll do this one here. So our changeover point for this is -3. We substitute -3 into both of these functions, and we see that one of them equals 10 and the other one equals -5. Because they have different y values, that pretty much means that there is going to be a gap when you are graphing these. You're going to have like a circle coloured in for this function here, because that's when x is equal to or less than -3. And you're going to have like an open circle for this function here, so that there will be a gap, so therefore it is discontinuous. You would have to lift your pen to deal with that gap. Hope this helps with the questions. Good luck.